Okay, so year 12s, I'm not here today, but you are going to do this lesson through this YouTube video. What you might need to do is have your notebook out, and you need to write notes. I'm not going to pause for you to actually be able to write them, so you might need to pause it as you go. Make sure that you have a pen and your journal out now. So if we go from here, we're going to be looking today at translations of exponential and reciprocal functions. So last lesson we looked at these, so we're going to start with looking at exponential functions. Now if you remember exponential functions or simple exponential functions, we have our key points. So for example, y equals 2 to the power of x, our key points are 0, 1 and 1 and 2. And 2 is that base number. We also know that we have an asymptote at y equals 0. So we're going to use the website we always use for these sort of translations, and all the rules are actually very similar to quadratics and to cubics. So if we have a look at graphing exponential functions, you've got the web address up the top there if you want to have a look at this. If we move through, we start off with our basic exponential function. So y equals 2 to the power of x. As you can see, it goes through 0, 1, and it goes through 1 and 2. If we then move on, we're then going to look at the different numbers. This is what we looked at the other day. So if the number changes from 2 to 3, it's still going to go through the point 0, 1, but this time it's going to go through the point 1 and 3. So those key points have changed. If we go y equals 4 to the power of x, those key points have changed again. So now it's 0, 1 and 1 and 4. You'll notice that if we change to a half, we've got the key point of 0, 1, and then we have another key point of 0 and a half, and it reflects that graph in the y-axis. So we looked at that the other day, so you might want to write some notes about that quickly. We might just say as the base number changes, as it increases, it gets steeper, but the asymptote stays the same. And as it becomes, if it becomes a decimal, it's reflected in the y-axis. Okay, and still the asymptote stays the same. Okay, if we now look at this and say, what happens when it becomes negative? So this is similar to when we looked at cubics or quadratics. What happens when it becomes negative? The graph is inverted, okay? So what happens is if we go from 2 to the power of x to negative 2 to the power of x, it's reflected in the x-axis. We can still call that inverted. And you'll notice the key points change to 0, negative 1, and still the base number 0, negative 2. So if we say 2 to the power of negative x, it's a bit like half to the power of x. Now we don't have to do this, it's not in the syllabus, so I'm going to skip that. So we're just looking at if the base number changes. So from positive to negative. So if the base number becomes negative, the graph is inverted. Key points are 0, negative 1, and then 1 and still the base number, so the same as before. The asymptote is still at the same point, so it's y equals 0, same space. Okay, moving on. If we add a number to the end of our power of x, if we add a number there, what do you think is going to happen as we move through? It's the same rule as for quadratics and for cubics. So if we go plus 1, it means the whole thing is moved up by 1. So our asymptote moves up to 1, our key point moves up to 0, 2. For if we add 2, our asymptote moves up to y equals 2, and our key point moves from 0, 1 to 0, 3. Negative 1, everything moves down. So it's the asymptote moves down, and then it's just in that same shape. So if a number is added to the end of the function, e.g. y equals 2 to the power of x plus 3, so that's where it moves. If it's added, it moves the whole function up. If it's subtracted, it moves the whole function down. So for this one here, it moves up by 3. Remember, including the asymptote. It's the same rule as for all the other functions. Okay, next one. Okay, if a number is added to the power of x, so you notice these are both really high up, just like in our EPW the other day, it's like there are brackets there. You can't see them, but we assume there are brackets there. So it's the same rules as when we had x plus or minus a number inside brackets for cubics and quadratics. So it moves it left and right, but it moves it to the opposite side. So if we say 2 to the power of x plus 1, for this one, we're going to move, it moves to the left by 1. If we say x plus 2, it moves to the left by 2. And you'll notice we pick those key points and we just move each point across by 2, and then we draw our line. For 2 to the power of x take 3, it moves to the right by 3. All of those key points. So for our notes, I messed up my colours, but that's okay. If a number is added or subtracted to the power of x, if it's added, it moves the whole function to the left. If it's subtracted, it moves the whole function to the right. Now, if you're actually drawing this, you need to, what I was saying about the points, if you're drawing this, now this is, just try and move it. It's alright, we can deal with that. Okay, so if we look at this, this is y equals 2 to the power of x. If we try and graph y equals 2 to the power of x, take x plus 3. It means everything moves to the left by 3. So we've got this key point here. We move it to the left by 3. 1, 2, 3. So that point there is now going to be there. Next point here, we move to the left by 3. 1, 2, 3. It goes there. Left by 3. 1, 2, 3. That point now goes there. A little bit further up. Halfway. Halfway. And so on. And so now we can just draw a nice sketch, remembering to go through the lines, remembering to put on arrows, and I can label that as y equals 2, x plus 3. Alright, that's pretty much it for exponential functions. If we just look at a couple of like mixed up shifts, just to practice. If we look at these, we'll only look at the first three, or first two. These are the sort of questions you get in a test. So you might get asked, what's changed from 2 to the power of x to become this? So for this one, you'd say it moves to, it's gotten steeper with key points at 0, 1, and 1 and 3 to start with before it's then moved. Then it's moved to the right by 1 and up by 2. For this one, you'd say it's inverted or reflected in the x-axis. Then it's moved to the left by 2 and up by 3. If you're having trouble with that, make sure you write it into your journal. You can pause this at any time. Okay, we're now going to look at reciprocal graphs. The good thing about reciprocal graphs is that, so for example, if we look at, let's say y equals 4 over x, you could also write this as x times y equals 4. You've got these points here, so you've got 1, 4, 4, 1, 2, 2. And the same on the other side. But what you don't see is that you have an asymptote here and an asymptote here. So if you move your function, for example, if I wanted to move it to the right, actually we'll say move to the left. So if I wanted to move it to the left by 2 and down by 1, I can actually move the whole asymptote. So I can go, okay, I'm going to move this to the left by 2, 1, 2, and so that asymptote is now here in pink. I then want to move it down by 1, so I'm going to move this asymptote down, and so at 1 I've now got this vertical asymptote. And I can then look at each point and I can move it from here. So 1 and 4 means I go 1 across from this center point, 1 across and 4 up. So I get to here, 2 across and 2 up. And 2 up, so I get to here. And 1 across and 4, so I get to here. Sorry, it's not very well to scale. But you can then sketch that line and the other line as well. But most of these we're not actually talking about sketching, you're just being asked how it's translated. So let's have a look at some different rules. So let's move. So same website, we're just going to change the top bit to hyperbola. Okay, so basic hyperbola is y equals 3 to the power of x. Remember those key points, so 1 and 3, 3 and 1, negative 3, negative 1, etc. Okay, I'm not going to spend too much time on this because you guys looked at it the other day. Alright, so if we change the number, as we move up, it gets further out, and those key points change. You know them. Alright, so what happens when it ends up being a negative number? We looked at this the other day. When I change it to negative 3x, all of the values change to the opposite quadrants. So we just write that down. We've already done this, so I'm not going to spend too much time on it. So if a, remembering that our function is y equals a to the power of x, if a is negative, the quadrants change. So y equals 2 to the power of x looks something like this. Y equals negative 2 to the over, sorry, not to the power, over x are in these quadrants. Alright, what about if we add a number at the end of the function? So if we add a number, same rule as before, plus 1 means we move up by 1. Notice in red it actually shows you the Cartesian, the asymptotes as they move up and up for this, okay? So then we go plus 2, the whole thing moves up by 2. Take 2, the whole thing moves down by 2. So, same rules before, if we add, it moves up, including the asymptotes. Remember that there are 2 of them. If we subtract, it moves down. Alright, so what happens if we add a number to the x value? So imagine it's like in brackets, because it's at the bottom of that fraction. Same rules as before, we move in the opposite direction. So x plus 1 means we move to the left by 1. X plus 2, move to the left by 2. X take 3, we move to the right by 3. So, if we add or subtract a number from x on the bottom of the fraction, it's a bit like having brackets. We move in the opposite direction. So if we add, we move left. If we subtract, we move right. Okay, there are our main rules. So all we now need to be able to do is these combined shifts, and then we're done. So we'll just try these 3. Alright, so this one here, we're looking at comparing to y equals 2 over x. Okay, so for this one, we're moving to the left by 3, and we're moving up by 1. So left by 3, up by 1. For this one, key points at 1, 4, 4, 1 before it moves, before it moves. Okay, then we're moving to the right by 1 and up 2. This one, it's inverted, which means it changes quadrants. We're moving to the right by 2 and up by 3. Now, we're not going to spend much more time on this. These rules you've learnt about before. So you guys need to make sure that you have notes on this and you understand it, because it will be in your test and your exam. Your homework will be told to you by your teacher. There will be a sheet, and there will be some work in your 2D book. It's expected that you get it done by Monday. Good luck.